Welcome to Software Heresy video number 4. For this video, we're going to talk about a topic that is near and dear to my heart, and I think this is going to be a fun one. And that's NoMocks. So I don't think you should use mocks, and I especially don't think you should use mocking libraries. So I have the usual warning. Heresy can be uncomfortable or even a bit insulting. One of my goals in this whole series is to perhaps cause you to re-examine some of your currently deeply held beliefs about what is the right way of doing software. And doing that is inherently going to be uncomfortable. Try not to take it personally, or try not to take it too personally. I want you to take it personally enough that you actually do that re-examination. So let's talk about mocks. And first of all, I want to talk a bit about coupling. And I think that coupling between pieces of software is probably my number one concern when I'm thinking about design. So I'm going to walk you through a little example here. So we're writing some software to do some payroll operations. And one of the things that we need to do for payroll is we need to report the withholding, how much tax we withheld for each employee to the IRS. So I'm going to write this little routine, and inside this routine, there's some code that knows how to calculate withholdings. So what else do I conceptually need to do in this routine? Well, I need to be able to get the records that tells me how much each employee was paid, so I can figure out withholding. So I have a payroll manager and a method on it called get pay records, and that talks to some database someplace. And then after I've done the withholding calculation, I need some way to notify the IRS. So I have a method called notify IRS on an IRS manager class, and it's going to do some sort of notification. I don't know what it is. It just has some method of doing that. So, looking at this, have the interesting question, how am I going to test this new function? And okay, looking at this structure, what do I need to do? Well, the first thing I need to do is mock out this call to get pay records. So my method report withholding for employee is going to call out to get pay records. And if I'm going to test it, I need a specific way to get a known set of pay records in. Now you can argue that I could just connect to a database with test data, and I might want to do that. It wouldn't be unit testing, and I'm deliberately wanting to do low-level unit testing so that I'm only testing the withholding calculator code. So I have to mock that out, and I'm either going to do this one of two ways. I might handwrite a mock. So I write a class called payroll manager test, and it probably inherits from a interface that payroll manager often also inherits from, or I might use a mocking library that allows me to essentially create an interface here and just kind of hook it up. And in addition, I'm going to have to mock the IRS manager call, because my method here is going to calculate the withholding and then send it off to the notification side. So I need to have a way of catching that call, storing the data away so that I can validate that it's correct. So I've written those two. Then I need to write my mock setup code. So I have the code in my test code that creates these two and then sets them up with the proper data. So my mock for payroll manager has to return the right sort of thing. And then I have to understand how the mock for the notifier will store the data. And then finally, I can write the actual testing code. Okay, so now I can go and test it. I said at the beginning of this that I'm going to talk about coupling. And one of the things I really care about with coupling is code knowing about other code. That inherently is what coupling means. But I always phrase it in this way. So why is this code, the code for the withholding calculator, coupled to this code, the code to fetch payroll records and the code to notify the IRS? The reason they're coupled is because of how we chose to write report withholding for employee. But it's not inherent in the problem. All withholding calculator does is take some payroll records and create some sort of withholding record. So it's really much more simple than that. And some of the problems I think we're seeing here, one of the reasons this is hard to test is because we have coupling here. So how could we get rid of it? Okay, so we have our same method, and then we still have our payroll manager and our IRS manager. But what I'm going to do is take withholding calculator, the code to actually do the calculate, and pull it out into a separate class, or I could just pull it into a static method. Either of those works. So now the actual code that does the calculations is in a place that is not coupled to these two other chunks of code. And now writing the test for it is really simple. I just hand withholding calculator some payroll records, and it returns me withholding, and I just verify that it's okay. And not only is it going to be simple to do, it's not going to break. There are very few changes outside of withholding calculator that I could make that would cause that code to stop functioning. So when I've done that, report withholding for employee now looks like this. So I call payroll manager to load the employee records. I get record collection back. I call withholding calculator to calculate. It hands me back a withholding instance, and then I call notify. Now the question I hope that you're asking yourself right now is, how are you testing this code? It's like, you modified things so you could test withholding calculator, but now you have some code here and you're not testing it. I thought you liked testing. My observation is that this sort of code either works or it doesn't. So there are no conditionals here, there are no calculations here. All it's essentially doing is getting data, passing it on to someone else. But if you really feel the need to test it, I have a nice way to think about that, nice way to approach it. Here's a little class that I wrote in C#. And it's a pipeline class. And the whole point of pipeline is that it takes a piece of data, transforms it to other pieces of data through a set of steps, and then finally hands off the final piece of data to someone who's going to do something with it. So in this case, I've shown only part of the pipeline class. So we have a process that takes a source that will get the data into process. It has transform 1, which takes the first data type, transforms it to the second, and then transform 2, which takes the second into a third, and then transform 3 that does something useful with it. And you can see that the implementation is really simple. I can easily extend this to different numbers of types, and I can unit test them all if I feel the need to. This is another set of code that's really never going to break, but I can easily test this. So what I'm looking to do with pipeline is make things work well in a way that works without having to test that code that I said I didn't really want to test. So here we are back at what we started with. So this was the code that I said I didn't want to test. How would I express this as a pipeline? And the way I think of it is a set of data types and then a set of transformations that kind of pass the data from one step to the next. So we have the employee ID. We pass that into a payroll fetcher. It returns a payroll collection. Pass it into a withholding calculator. It returns withholding instance, and then we pass that to an IRS notifier. Now, the important part here is none of these pieces of code need to know about each other anywhere at all. They are coupled, instead of by code and interface with each other, they are coupled through data types. And this goes back to my point of being comfortable with data types that I made in the last video. Now, I would generally call these, sometimes they're called just plain objects. Generally, these objects have very little behavior associated with them. They mostly just hold data. So if I want to implement this, what does that look like using the pipeline class? Well, it's really very simple. So first of all, on the first line for the source, I have this kind of strange syntax here with the parentheses and the equals arrow. So it's called a lambda in C#. So you can think of this as a nicer way of writing a function that just returns an employer ID. So that matches the source for the pipeline. Then I just have payroll manager load for employee. That's the first transform function. Then I have withholding calculator.calculate. That's the second transform function. And then I finally have IRS notifier.notify. That's the sync that's going to take the withholding and do something useful for it. And that's the end of our pipeline. So what I've got here with this architecture is I've now separated these things into nice individual discrete steps. And they're coupled by this generic pipeline processor. And that verifies that the code that I said I didn't need to test is very simple. It's just expressed as part of the pipeline. So that was my first example. I don't want to bore you by going into depth for each of my other examples. So I decided to just do kind of a top level overview of the issues that I think come up. So the first one is that if you're using a mocking library, it requires learning a new language. So if I'm doing mocking libraries in C#, each of the mocking libraries has a specific way of expressing itself that's not C# code. It's something else. Now, if I hand mock, I can build mocks with normal C# abstractions and constructs. So hand mocking wouldn't require me to learn a new language, but mock libraries almost universally do. And sometimes I end up with code that uses multiple mock libraries, so I have different languages that I have to learn. Number 5, mocks require writing, maintaining, refactoring extra code. If you've watched the earlier NoTD video, you will remember that the number one complaint against TDD is it's too hard to maintain the tests. Guess what? If you have mock libraries, or mocks to some extent, it makes your code much harder to write. Remember in the earlier example, I showed you the coupling. Whenever you have coupling, that means that your tests are more fragile. There are more things you can change that would require a change in the test. Number 4. Mock libraries encourage behavior-based architectures. And I don't know if it's purely encouragement. I think there's synergy. If you like behavior-based architectures, you inherently have to do mocking, and mock libraries look really like a very convenient way of doing that. If you watch my video on Solid, you understand that I don't like behavior-based architectures because I don't like the coupling that you get. And in the earlier example in this video, you saw I didn't like the coupling we had there. I thought it was extraneous. Number 3, the mocking code itself is untested. This is actually a pretty big deal. The problem with it is that we write code, it's expressed in this weird way of expressing things, and we don't actually write tests for that. Now, the assertion when mocking was young was that mocks would be very simple and therefore really wouldn't require testing. And it turns out that if you handwrite mocks, that is generally the case. Not only are handwritten mocks very simple, you can actually easily write unit tests against your handwritten mocks. So, but when you start using mocking libraries, you end up with lots of code that's untested. The second problem is that mocking code is often duplicated. And the real problem I see here is I'm writing a test for some code, and I choose to use the mock library to write it. So in my test, I have the mocks that I need. So I've written them, and they're expressed programmatically using whatever syntax the mocking library uses. So I write them, and then I write my test code, and it's all together in a bundle. And then I need to go and write a second test. And what we would like to do at that point is recognize that the code for the new test is going to be duplicated, or at least some of it's going to be duplicated. And we don't like duplication, so we're going to introduce some new abstraction that means we don't duplicate. The problem is there's not really an obvious abstraction there. And the simple thing to do is to just cut and paste just to duplicate that test code. And then we change it so that it works for our new tests. So now we've got two instances of the test code. And over time, we do this a few times, and eventually we have 5 or 6 instances of the test code, all of which are subtly different, because they're trying to do slightly different things. Some do more mocking, some do minimal mocking, and this is one of the things that really drives the TDD tests being too hard to maintain. I have to look at 6 different tests. I don't know how the mocking is different in each of them, and it's very hard for me to update them in ways that is simple and easy. So this is another reason why I'm a big fan of handwritten mocks. With a handwritten mock, I go and I write my mock code in a separate class, and then when I go to write a second test, I'm still going to do cut and paste, but it turns out that cut and paste does not duplicate my handwritten mock because it's already an abstraction. So that inherently makes it a lot easier to keep your code in better state. And then if I need to change something, I need to update it. Well, there's one place I'm going to have to update. I'm going to have to update that mock. And maybe the code that calls it, but mostly I'm going to have to update that mock. And finally, my number one reason. Mocking libraries make testing easy, or too easy. If you remembered back to the video on no TDD, I talked about the writing test step and how one of the goals of doing TDD when you get to write a test is to look and see how hard it is to write the test. And if it's hard for you to write the test, that's a pretty good indication that, hey, maybe there's something architecturally problematic here. Maybe we should go and explore how to refactor this so we can make writing the test easy. My experience is that the use of mocking libraries makes that much less likely to happen. So it's really common to see code that has a mock. So I create a mock, and then I create another mock, and then I create a mock of a third class that can return instances of those two mocks. And I end up just with a lot of complexity here, but I can actually express it without doing any refactoring. And so that's typically what happened. So that's the general feeling I have for mocks. I think hand mocks are okay in some cases, although as I showed in Pipeline, there are ways to architect your code so that you don't need to have the mocks. Oh, and for those of you who looked at my Pipeline example and said, hey, this looks like functional code, you're correct. So in general, what I think is the best mock is NoMock. If you can do things with value objects and very loose coupling, the way I did in the Pipeline class, that's clearly the best. If you do need mocks, and I think there are cases where you need mocks, then I think handwritten mocks even though they take a little more time up front, are far superior to doing mocking libraries. Now, I do see a case where you can argue that mocking libraries are a good thing. It's the case where you are doing something in existing code. You really need to do what would be called pinning tests. You want to keep code from moving around, and you need to pin it in place, and you don't want to modify the code. In general, I think that's by far the exception. And since I don't think you should, in general, be doing TDD on that sort of code in the first place, I think you should try to avoid mocking libraries in general. That completes this bit of heresy. Thank you for your attention. I hope you'll come back for the next video.